This question is about projectile motion taken from I M24 paper 2 time zone 1. Okay, so let's read the question. In this question it says that a student throws a ball towards the wall, and you see that it from how far this ball is thrown, that is 8 meter. So we can say it is also a horizontal distance, right? So let's call it x, for example. And at what angle the ball is thrown, that is 48 degrees. And they have mentioned here that a resistance is negligible, which makes it the free fall motion, right? So it's already a two-dimensional motion, so we would say free fall two-dimensional motion, in which our next step is to revise it, that acceleration due to gravity is negative g. So if this is a point from where the ball is thrown with some initial velocity at an angle 48 degrees, so what will be the trajectory of the ball? It's a free fall motion, so you see that the ball is moving like this. So when I am saying acceleration due to gravity is negative g, now dear students, it means that wherever the ball is, the acceleration due to gravity is directed vertically downward, even at the maximum height. At all the points it is negative g, because velocity is increasing, velocity is changing uniformly according to this graph. You know very well that will be like this, velocity time graph. So we see that the ball, when the ball is thrown, this ball has already some position from the ground, that is 1.8 meter. And in this first question they are saying draw the velocity of the ball at the point B. So basically at the point B we have to draw a vector, because velocity is changing its direction continuously, because I have shown you this curved path of the ball. So what will be the direction? So you have to just draw the tangent at point P, but remember that this velocity at the point P must be less than its instantaneous initial velocity. Okay, so this is a velocity at this point. So we will label it with this letter V. Okay, so now our next question is the acceleration of the ball at B. So I had already explained you the acceleration throughout the motion is constant, and that is downward, vertically downward. So at this point the acceleration due to gravity should be a vector negative g. Okay, this one. Now the next question, this ball takes 1.3 seconds to reach the wall. It means that as the ball is going towards the wall, so for example, if the ball is thrown from this point according to the diagram and at an angle of 48 degrees, so this is a instantaneous initial velocity, so we can say it is u. And what is its trajectory? I had already shown you, like this is a trajectory. Okay, now according to the question, the ball takes 1.3 second to reach the wall. Now we know in this 1.3 second, this ball has covered how much horizontal distance? You know that this horizontal distance is 1.8 meter. Okay, so either the ball has hit the building, or the ball has at what level the ball is. Maybe the ball is at this point, or the ball is at this vertical position, or the ball is at this vertical position. We don't know about that. So ball has taken 1.3 second to cover how much horizontal distance, which I have stated here, 8 meter. Now show that the initial speed of the ball is about 9 meter per second. Okay students, so now if we make the components of this horizontal is instantaneous initial velocity, so you see that there are the two components, the x component and the y component. And students, you know that the x component is u cos of theta, and we know that the u cos of theta is basically the component of the motion of the velocity which will take the object horizontally, whereas this u sine theta is the component of velocity which will be responsible for the vertical motion. All right, so we can say ux which is u cos of theta, object will cover horizontal distance or the ball will cover horizontal distance. So even if you apply the Suvat equation, so S is equals to ut plus half at square, but now we will use the x component of motion. So that's why I can replace S with this x, which I'm writing it, and this is ux, and this is acceleration due to the x component of motion. Now you know that because air resistance is negligible, that's why students, there is a no force along x-axis and there's a no acceleration in this ball in the direction of x-axis. So that's why the velocity along x-axis is constant. Okay, that was a quick reason. Okay, now so that's why on this basis we can make it zero because there's a no acceleration. So that's why you can directly apply this equation. Okay, so u cos of theta times t. So horizontal distance is 8 meter is equals to initial velocity is unknown, whereas the cos 48 degrees into the time 1.3. Okay, now what is advantage from this equation? Because we will get the value of u. So u must be equals to 8 over 1.3 and cos 48 is 0.67. Yes, 0.67. Okay. So my answer is 9.19 meter per second. And as they said, our answer should be close to 9 meter per second. So you can see. Now this is a initial velocity that we have calculated, 9 meter per second. But as the ball is going up, this horizontal velocity is not changing, but the vertical component of velocity is decreasing. And at the maximum height, the vertical component of velocity is 0. Now in our next question, they say determine the height above the ground at which the ball hits the wall. Okay, now you remember a few minutes ago I told you that ball is taking 1.3 seconds to reach the wall. At what position the ball is at that moment of time, we don't know about that. So that's why when the ball will reach at this position, means 8 meter away from the initial position, uh, either the ball is here or here, right? We have to find out the vertical distance, the height above the ground at which the ball hits the wall. Now once again we will apply the Suvat equations because it's a projectile motion, it's a two-dimensional motion, it's a free fall, so you can apply Suvat for this. So for this, do we have all the data? We have to confirm it first. So for this, I will consider once again the path of the ball. Now to explain you more clearly, okay, we will consider the initial and final position, right? So this is a path of the ball, trajectory of the ball, right? What is its initial position? That is 1.8 meter. Now this is the initial position of the ball. So you remember I told you that the vertical component of the velocity is responsible for the vertical motion. So when we calculate the time taken, we usually utilize the vertical component of velocity. So we have the value of u sine theta at this moment, but the question is that do we have the velocity at this point? That we don't have. So we will avoid that equation in which we need the final velocity. Okay, what's the problem? I explain you again. When the ball will reach this building, okay, we don't know the final velocity. Okay, we don't know its vertical component of velocity. So we should avoid the three equations which have all this final velocity factor. You understand? So only one equation is left. That is a logical reasoning. The equation that is left is S is equals to ut plus 1 over 2 at squared. Now how to utilize this equation? Let's say that this distance is, you see, which distance from this level to whatever the ball, wherever the ball is, let's say here. So let's say this is y. Okay, and this is, let's say, y prime. Okay, 1.8 meter. So it, when we will calculate the value of y, I will just add into this y prime. Okay, now I told you that we should use this equation y because we don't need now the final velocity factor. So let's put the values. First of all, I will find out which height. I will find out this height, which I said y, right? So this is the positive displacement because that's upward. Okay, so that's a positive y is equals to initial component of velocity, y component of velocity, times t plus 1 over 2 into negative g t square. Now we can easily find it. Let's put the values. It is, you know, that's a u sine theta 1 over 2 gt square. Now u sine theta value is 9 sine 48 should be 6.82 or 6.83 times 1.3 minus 1 over 2 into 9.8 into 1.3 square. So our answer is 0.6 meter from that level. Okay, so which means that if its value is 0.6 meter wherever, what is its height from the ground? As you know, it is 1.8 meter. So what is the total height of the ball at the 1.3 second? So for this we can just simply add these two, and that will be 2.4 meter above the ground. So it is 2.4 meter. But not least, if you want to use some other equation of motion, so then I told you you need this y component of motion. So for this, let's say, if you, how you can calculate that, we know Vy is equals to Uy minus Gt. So first you can calculate the Vy, the vertical component of velocity. So you know that's a u sine theta minus g and t. Time and initial velocity, everything we have already. So you can find first Vy, and then you can apply this equation. Vy square is equals to uy square plus 2ay and the distance covered. Okay, let's say it's the y. So then you can apply this equation. So you see it's a longer method. It's a two-step method.